Hey everyone, if you've been enjoying my free math lessons on Prodigy Mathematics, I've got a great way you can support the channel and supercharge your learning. I've launched Martian Mathematics, a growing collection of problem sets, quizzes, and fully worked out solutions designed to complement my videos. These aren't just generic worksheets. Each set follows my lesson structure, reinforcing key concepts with carefully crafted problems and step-by-step solutions. Every purchase helps keep this channel running, so I can continue bringing you high-quality, free math education. Check out Martian Mathematics on Teachers Pay Teachers today. Your support makes all the difference. And don't forget to like and subscribe. Lecture 18, Cartesian Coordinate Graphing. So the topic of today's lecture pertains to some work done by René Descartes back in the late 16th, early 17th century. And so his ambition was to kind of unify or bring together the fields of geometry, which is kind of the studies of shapes and figures, and algebra, which was kind of a new and emerging concept back then. Now, I realize we haven't talked about algebra yet, but we can at least explore the basics behind the Cartesian coordinate system. It's called Cartesian. That's the Latinized version of Descartes. Basically, what the Cartesian coordinate system is going to do, otherwise known as like the XY plane, is it's going to marry two numbers together using two number lines that are orthogonal to each other. Orthogonal means perpendicular, so they make 90-degree angles to each other. So I think probably the best way to illustrate it is to actually look at it in some detail. So if you look at this first horizontal line, this is called the x-axis. And it's exactly like a number line. You'll notice the other line is a vertical line, meaning that it is perpendicular to the x-axis, you see? It's at a 90-degree angle. But it also is a number line, exactly like this one. So it's as if we took this number line, changed its name to y, and we rotated it around 90 degrees. Does that make sense? So why in the world would we ever want to do this? Well, the purpose of this is as a graphical way to express algebraic equations. So I guess I have to show you an algebraic equation for you to understand that. And a classic algebraic equation might be something like y equals x. So it expresses an equality. We have a left-hand side and a right-hand side. The left-hand side we usually think of, I could make it a little bit different. I could say x plus 1. The left-hand side we call the dependent variable, y. That's the one that appears all by itself, and by convention we usually put that on the left-hand side. On the right-hand side we have what is called the independent variable, in this case x. And basically what this says is the formula. It says take any number x that you want, and to get the corresponding y value for that, simply add 1 to it. So if I said, well, if x is 0, that means that y is equal to 0 plus 1 or 1. If x is equal to 1, y is equal to 1 plus 1 or 2. You see? So that is a very simple algebraic equation. And that is what Descartes was trying to find a way to represent graphically. So we're not going to worry about equations so much this time. I do want you to see what the motivation behind the x and the y-axis is. We think of the x-axis as the independent variable. That's the one that can have any x value that you want. And the y-axis as the one that is dependent on what the x value was. Okay? For today's lesson, we're not going to worry about that. We're just going to take x, y number pairs, called an ordered pair. So, right down here, ordered pair, where we take numbers in the form, first we'll have an x value number, and then we'll have a y value number. So if I gave you 1, 1, that means x equals 1, y equals 1. If it was something that matched this equation, if x was equal to 1, then y would have to be equal to 1 plus 1 or 2. So 1, 2 would be the resultant ordered pair for x equals 1 from that algebraic equation. So I don't want to distract you too much with the algebra. But so here's the graph, and there's some features we need to note. So for starters, this horizontal line is called the x-axis. The vertical line is called the y-axis. At the very center where these guys cross, we call this the origin. That's where x is equal to 0 and y is equal to 0. So you can see that we've got some negative numbers in here, because anything to the left of 0 must be a negative number, right? So if we called this x equals 1, x equals 2, x equals 3, 4, 5, 6, and 7, then this would have to be minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and minus 7. And the same thing for the y-axis. So for the x-axis, going to the right means we're going more positive. Yes? For the y-axis, going up makes it positive. So this would be 1, 2, 3, 4, 5, 6, and 7. Whereas this would be -1, -2, -3, -4, -5, -6, and -7. Make sense so far? Again, the center is 0, 0. That's where x equals 0 and y equals 0. We call that the origin, kind of home base. Now, what do we put on these graphs? Well, what we put on these graphs are points. So here, for example, would be a point. It looks like this. And we can describe this point, which is intrinsically kind of a geometric, it's a geometric thing, right? It's a point somewhere in space. But we can identify this point with numbers by using this ordered pair concept. So what we would do is for this point, we would write down what is its x coordinate. Coordinate, there's that word, right? Its x coordinate would be, well, how far in the x direction do we have to go to be where this point is? Well, we have to go 1, 2, 3. You can see that this point sits right above the 3 on the x-axis. So we put a 3 here because the x value comes first. Now, what is its y coordinate? Well, we have to count up 1, 2. It looks like this point is directly across from 2 on the y-axis. So that is its y coordinate value. So this is the point 3, 2. Make sense? Yeah. And so I've put the ordered pair next to the point itself. You don't always have to do that, but in this case we will. Just so we can, kind of get used to these points and these coordinates. So what words do we have so far? So we have some terms that we've come across. We had ordered pair. We had points. That is a point. It just simply marks a location in space. Okay. We had x-axis. We had y-axis. We had origin. That's that special point, right, where the two axes cross. We had coordinate. So if you were going to you're going to have a party, let's say, and you were going to have some people serving food at this party, and you were going to have people serving some drinks at this party. You would have to get those two people to coordinate their activities, right? To work together. Co, coming from com or con, meaning with, together, or completely. Ordinate, order, right? The ordering of it. So they're going to have to kind of work together so that the drinks are served, at the same time, for example, as the food is. Or that maybe it's the right drinks. Maybe if you were serving wine, and when you have food, if you're having dark meat, you want to serve red wine. If you're having white meat, you want to serve white wine. So that's coordinating. And that's kind of what we mean by coordinate when we say the x-coordinate and the y-coordinate, because they're working together to describe this point. What other words do we have? Vocabulary words associated with this. There's one last one I can think of, and that is the word quadrant. So what does quadrant mean? Well, quad, anyone recognize the prefix quad? No? If I had something I called it a bicycle, you know what that is, right? How many wheels does it have? 2. And if I had a tricycle? How many wheels does a tricycle have? 3. It has 3 wheels. Tri means 3. If I had a quadcycle, how many wheels do you think it would have? 4. Yes, so quad comes from the Latin for 4. And what it's describing is the fact that, do you see how there are these kind of 4 distinct spaces on this graph? Yeah. Graph, by the way, just means picture. 1, 2, 3, 4. So we label these quadrants as quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And yes, we do use Roman numerals to label them by convention. So if I were to ask, what's the location of this point 3, 2, you would say it's located in quadrant 1. Let's go back to this point that I've plotted, 3, 2. And let's note that the 3 is a positive value. Now, the positive value of the x-coordinate tells me that the point will lie to the right of the origin. The positive value on the y-coordinate tells me that it will lie above or up from the origin. What if I had, say, a negative x value, but a positive y value? So something like, What if I wanted to plot the point -2, 1? Here, the x value is negative. Well, if positive means to the right, what do you think negative means?
To the left.
To the left. So that means that I'm going to go 1, 2 to the left, but my y value is still positive, so I should still go up. So I should go up 1. So I would walk across 2 to the left, and then I would have to walk up 1. And this would be the point -2, 1.
Yes.
And that would put this point in the second quadrant. Let's look at a few more points. What if instead of -2, 1, what if I asked for the point, let's say 2, 0? The x-coordinate being 2 and positive would tell me to go 2 to the right. So I go over 1, 2. The 0 tells me what? Where is y equals 0? Where should I put this point? Any ideas? Well, remember, the origin is the point 0, 0. That's where x is 0 and y is 0. So the x-axis is itself a place where y is always 0. So I'm going to put that in parentheses, but in a different color. The x-axis is a place where y is equal to 0. That's actually an equation, isn't it? The equation y equals 0. So if I want to go over 2 and up 0, I guess I just stay right here on the x-axis, huh? And so that would be this point right here, 2, 0. Does that make sense? Now, where is that point located? Is it in quadrant 1, quadrant 2, quadrant 3, quadrant 4? What do you think? Well, it's in none of those quadrants, right? So to describe the location of that point, we would simply say that it lies on the x-axis itself. You see? Now, similarly, we could have a point that lied on the y-axis, because the y-axis could be described by the equation x equals 0. Right? Everywhere along the y-axis, x is equal to 0. So if I had the point 0, 5, it would be right here. So that's the point 0, 5. Can somebody give me a point that would put me in quadrant 3? How would I be in quadrant 3? What would I need? What would a number need to look like? Or what would the coordinates need to look like for me to be in quadrant 3? Well, if you don't know, just put your finger down somewhere, right? What if I put my finger down right here? Well, I look up at the x-axis. So here, I'll put my point right there. And you'll notice that that intersects the x-axis at -2. What about the y-axis? Well, it intersects the y-axis right here at -4. So the coordinate, the ordered pair for this point would be -2, -4. Notice that both of these are negative. So if I see a coordinate, if I see an ordered pair with a negative x value and a negative y value, I can be sure I'll find that point in quadrant 3. Now, how about quadrant 4? If I want to put a point in quadrant 4, what would that look like? Give me an ordered pair that would fall in quadrant 4. Well, look at me. Look at the graph. Where's quadrant 4? Is this quadrant 4?
No.
That?
No.
This?
No.
Over here?
Yes.
Yes. So imagine a point there. Here, I'll put my finger out. Tell me when you want me to stop.
Stop.
Right here?
Yeah.
Okay. There we go. So what does that coordinate look? What would the ordered pair describing that point look like? We can draw a little dotted line. So what are we going to get? What is the x value? 4. And the y value?
-2.
-2. So if we look at these example points we have here, right, we see positive x value, positive y value, quadrant 1. Negative x value, positive y value, quadrant 2. Negative x value, negative y value, quadrant 3. Positive x value, negative y value, quadrant 4. It helps a lot if you have graph paper. I'm going to erase the quadrant names too. So I'm going to give you a point, an ordered pair, and I want you to plot that yourself. You'll pause the video, come back when you have your answer. If you have graph paper, that's very useful to do this on because you've got these grid lines that cover the entire space, so it makes it easier to locate points. Otherwise, you have to kind of do it by eye. You're like, well, I go over 3 and I go down 4, about here, I think. Yeah, graph paper makes that really easy. So if you have graph paper, use that. I think I provide graph paper inserts for the homework problem so that you can just use the graph paper there. But let's try plotting the point. Plot -3, 4. Maybe I'll give you a couple to plot. Also plot 4 -3. Yes, just do 2. See how you do with that. So go ahead and pause the video. Come back when you have your answer. All right, let's take the first point, -3, 4. So -3 tells me go 3 to the left. So starting from the origin, I go 3 to the left. Then the +4 tells me to go up 4. So 1, 2, 3, 4. So you can see, if I were to kind of pretend that I had graph paper, right? I have these grid lines that would come out from the -3 and from the 4, and where they intersect, that's where my point lies. And so this is the point, -3, 4. How about this other point, 4 -3? Well, the 4 tells me to go from the origin, 4 to the right, so I go over here to 4, and then the -3 tells me to go down 3. So 1, 2, 3. And again, if I had graph paper, I'd have these nice grid lines that went all the way across, and where the 4 grid line on the x-axis and the -3 grid line on the y-axis intersected, that's where my point would lie. And so this would be the point 4, -3. That's not too hard, huh? Yeah? Everyone get it? Good? Plot the points 3, 2 and the point 0, 0. So go ahead, pause the video, try that at home, come back when you have your answer. All right, 3, 2. Well, that tells me from the origin, go over 3 and up 2. So I'll go over 3 and up 2. That's going to put me about right here, yes? And that's the point 3, 2. What about the point 0, 0? Well, that's just the origin, right? That says from the origin, go to the right or the left, 0, and go up or down, 0. So I just stay at the origin. So here I am at the origin. That's 0, 0. Now let me ask you this question. How many points do you need to construct a straight line? A unique straight line. If I just gave you 1 point, there's an infinite number of straight lines I can make from that, right? I could make this line, I could make that line, lots of lines I could make, yes? But I want to make a unique straight line. How many points do I need to do that? I'll give you a hint. It's more than 1.
2.
Yes, it's 2. What about 3? Can I do it with 3? Well, let's see. Here's a point. Here's a point. There's a point. Now, how am I going to get a straight line to go through all 3 of those points? I can't. That doesn't mean I couldn't have 3 points that lie on a straight line. But 3 points that are arbitrary, I cannot use to just make a straight line. 2 points is what I need to make a straight line. We have 2 points here, yes? Let's make a straight line. So we get our ruler, and this is actually called a line segment. See that? That is a line segment. I could, if I wanted to, extend that as far as I wanted, and I will extend it with the dotted. You see? I could extend that as far as I wanted to. But this portion of it anyways is called a line segment. If we extend it out to infinity, then it's a line. This is the figure that we're going to focus on in our graphing, okay? Straight lines. Now, we're not going to write the equations for straight lines. That's something you do in algebra, and we'll probably do a little bit of that in our lesson on algebra, but not to any great degree. But we can still say something about this line. Do you notice this line has kind of an orientation? It's kind of going up and like this, right? If I were to plot another line, let's say with the points, I'll even make it share the same point. It'll have a point 0, 0, but maybe another point down here at 3, negative 4. Yes? So 3 minus 4. And make a line out of those two. You'll see, I can extend that one as well. That line looks different, doesn't it? That one seems to be going down.
Yes.
So we can describe the orientation of the line using a quantity known as the slope. And so when you hear the word slope, what do you think of?
Sloppy.
Sloppy, huh? Now, that's not what I think of. Most people would probably think of a ski slope. Have you ever heard of a ski slope?
No.
Never heard of a ski slope?
No.
Have you ever heard of this thing called skiing?
Yes.
Yeah, that's where people put boards on their feet and they go flying down hills of snow at high speed, hopefully not into a tree. Well, could you do that effectively, say, on flat land if it was just flat? Kind of have to push yourself along. That wouldn't be nearly as much fun as if you had a nice hill, right? That's the word slope. So when you hear slope, think hill. And we define the slope of a line as follows. You need 2 points. So I'm going to write line. You need 2 points. We'll call it point x1, comma y1, and another point x2, comma y2. So the subscript 1 in the first ordered pair simply reflects the idea that that's point number 1. The 2, the subscript 2 in the x sub 2 and y sub 2 in the second ordered pair indicates that that is for the point we've labeled 2, or the second point. So the slope of the line is defined as the ratio of y2 minus y1 divided by x2 minus x1. Some people will call it rise over run. So the rise is how much I go up or how much I go down.
Yes.
The run is how far over I go to the right or to the left. Now it's really important that the first number, it doesn't matter which one you call point 1 and point 2. What does matter is that you make sure that the y-coordinate you use first here in this subtraction is going to be the same as from the same ordered pair that the x-coordinate that you use in the denominator. If I switched x2 and x1 here, we would get the wrong value for the slope. So let's look at what the slope of these two lines are that I've drawn. And usually slope is labeled with the lowercase m. I don't know why. I have no idea. I'll look that up. But usually we use a lowercase m. I know it's not German because I think I asked someone from Germany once whether it was a German word, and they said, no, we use a different letter. So they don't use m there. So I'm not sure where it comes from. But well, first let's identify what the points are. So above here, I'm going to write the points. We've got the point 3, 2 and the point 0, 0. Those are the 2 points for our line, this one and this one. Again, I said it doesn't matter which one you call point 1 and point 2, but we just have to stick with it. So if I start out with the y value, y2, let's say this is y2 here, the 2. 2 minus the other y value is 0. Now, if I wrote 0 minus 3, that would be bad because now I'd be switching things up, you see? The 2, which is the first number here, came from this ordered pair, so I have to use the x from this in the denominator, right below it, you see? 3 minus 0. Well, that's easy. 2 minus 0 was just 2, and 3 minus 0 was just 3, so the slope of this line is 2/3, or 2 over 3. That means that it goes up 2 every time it goes over 3. That's what that means, the rise over the run. It rises up 2 units every time it runs over 3 units, I guess. Runs to the right, 3 units, something like that, okay? Well, let's look at the slope of this line. This line was constructed from the points, we had 3, minus 4, and 0, 0. So its slope, what's it going to be? Well, let's start with this one again as our second coordinate. So minus 4 for y. May as well go ahead and put the 3 in below it. That's what I suggest doing so you don't make a mistake, all right? Write your division bar, write the minus 4 from the y-coordinate of the first ordered pair, and then directly beneath it write the x value from that same ordered pair, you see? Then put in your subtraction signs. and then put in the y value from the other one, 0, and the y value from, or the x value from that one, 0. And so what do we get? We get minus 4 minus 0 is still minus 4, and then 3 minus 0 is 3, and so we get minus 4 over 3. This is a positive slope, meaning that it rises up, whereas slopes that go down are negative slopes, you see? So negative slope, those are the ones you want to ski on, or ride your bike down, right? Makes it easy. You don't want to ride on the positive slopes because that's going up and you have to do work to get up there. The vocab is kind of cluttering things here. I think I'll erase that. All right, so we can construct lines from 2 points, and we can describe those lines by their slopes. The last thing I'm going to teach you how to do with Cartesian coordinate graphing is how to find the midpoint of a line. What do you think the midpoint of a line is? Point in the middle? Yeah. So let's do an easy case first. I'm just going to draw a little line right here, and it's going to be, actually let's do this way. I'm going to make this line 10 centimeters long. All right, it's too short. Let's make it 20 centimeters long. Where should the midpoint be? And I could measure that by, if I know this line is 20 centimeters, how could I find the middle? I could put my ruler down. I could say, okay, wherever 10 centimeters is, that must be in the middle because half of 20 is 10, yes? Well, that was easy, right? And you could do the same thing by laying your ruler out over this, but we're actually going to do it a little bit differently. Let's make a line between the point 1, 1 and 5, 5. So we'll go up and over right there. So we've got this point 5, 5. And I can make a line or a line segment between them, between those points with my ruler. And now I want to find the midpoint on that line. And so the way I'm going to do it is very similar to what we did with the ruler. Right, where we said, well, we've got 20, with the 20 centimeter line. We had this 20 centimeter line. I said the midpoint was at half of 20 centimeters. But that's because we started at 0. Here we're starting at 1. So we'd have to add 1 plus the difference in the endpoints. So we'll say x mid. That's the x midpoint. And we'll have a y midpoint. And that would be 1 plus 5 minus 1 over 2, which of course would give us 1 plus 4 divided by 2 is 2, which gives me 3. But this is also just the average of these 2 points. I could have written it as 5 plus 1 divided by 2, which is 6 divided by 2, which is 3. And I can do the same thing for the y midpoint. And since the y midpoint also has a 5 and a 1 in it, it will also be 3. And so I have an x midpoint of 3, a y midpoint of 3. Let's just put them together and say that the midpoint is going to be 3, 3. So we go over 1, 2, 3, and 1, 2, 3. And there we are at the midpoint. And as you can see, it looks like it actually is the midpoint of that line. So the midpoint, well, we'll call it the midpoint formula. It's just the average. So we would write x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And that will give us the midpoint for any line that we wish, simply by averaging the x-coordinates and the y-coordinates for the 2 points that define the line. The slope we find by taking the difference, the rise over the run. So y2 minus y1 divided by x2 minus x1. Make sense?
Yes.
Okay. Let me ask you this. What if I had a line that was flat? What if I had this line right here going through y equals 6? It doesn't seem to be rising or descending. So what do you think the slope of that is? Is it positive? Negative? Remember, positive slopes were rising lines. Negative slopes were descending lines. What would we do if we were a flat line? What's in between positive and negative?
0.
0. Well, we can wadir it and find out, right? What is the slope of this line? I just picked 2 points on it. Here's one at x equals 0, y equals 6. Here's another one at x equals 4, y equals 6, right? Because y equals 6 everywhere on that line. The slope is equal to y2 minus y1. Well, that's 6 minus 6 divided by, doesn't matter, x2 minus x1. Well, 6 minus 6 is 0, so this is 0, yes? So that's the slope of 0. If you have a flat horizontal line, that line has a slope of 0. Well, what about a vertical line? What if I had a line going through x equals minus 2? Such that here we would be minus 2 comma 0, and maybe up here we would have minus 2 comma 5. I use the slope formula. I get my first y value, 5, minus my second y value, 0. And then I have minus 2, minus minus 2. Minus a minus is what? Minus times a minus is a... Yeah, so when we have minus a minus, that makes it positive. So now I have plus. I have minus 2 plus 2. What is minus 2 plus 2?
Minus 0. 0.
0.
Hey, you said that.
So this is equal to 5 over 0. But we can't divide by 0, can we? That's not allowed. We can't divide by 0. So this slope, we call it undefined. This slope is undefined. So the slopes of vertical lines are undefined. Okay? And I think, yeah, that is all I have. Any questions?
What's the next lesson?
I think it's on geometry of triangles, I believe.
Yes.
Triangles?
Triangles and quadrillions.
Quadrillions? You mean quadrilaterals. Okay, so the next lecture will be on triangles and quadrilaterals. That sounds right. No.
How about you were up all day?
Oh, do I have the homework for this? Yeah, of course I have the homework for this. It's already printed out. I'll hand it to you in just a moment. That's all I have for you. I'll see you next time.